Hello everybody and welcome to this new episode of Elite Dangerous Science. So today, as the title suggests, we're going to talk about space missiles, or rather missiles in space in the universe of Elite Dangerous, how they work, how they probably work. Obviously there's a lot of speculation that goes into those videos, but hopefully you find it interesting and insightful. So the way I'm going to do this today is I'm going to compare missiles in Elite Dangerous with missiles today, and I'm going to go over the dynamics of missile flight, propulsion, attitude control, and finally guiding systems. And I'm going to do a parallel between how missiles work today and how they seem to work in Elite Dangerous. The primary difference between missiles we use today and missiles in Elite Dangerous is that missiles in Elite Dangerous are designed to operate mostly in vacuum, whereas missiles we use nowadays obviously operate in an atmosphere. And so this completely changes the dynamics of the flight of the missile. Although the presence of an atmosphere complicates the equations of motion for a missile, the presence of an atmosphere actually makes the engineering a bit simpler. So although this seems a little counterintuitive, the reason for that is, for example, the maximum speed of a missile. If you take a missile using a solid propellant, the thrust is constant on the missile. So according to the second law of Newton, once you ignite your engine, the missile will accelerate as long as the engine is on. Now, in an atmosphere, eventually the thrust of the engine will equal the friction forces as it speeds up. So eventually it reaches a plateau speed, a cruise speed, I guess you could say. And so it's possible to analytically determine that cruise speed. And so it makes the whole guiding system then much easier to design for engineers, because they know their missile is going to be cruising at a max speed of Mach 5 or 6. And so they can kind of go from there and just use a constant speed for their equations. The second advantage of atmospheric flight is that you can use control surfaces for attitude control on your vehicle. Finally, flying in an atmosphere allows you to neglect the effects of gravity to some extent, which you cannot do in vacuum. The way this works is if you do a fluid mechanics analysis of your missile flying at Mach 6 or 7, you'll realize that the fluid term is orders of magnitude smaller than your kinetic term. So in other words, the kinetic forces due to flying in an atmosphere at high speeds completely dwarfs the force of gravity. Alright, so now let's take a look at how missiles seem to operate in Elite Dangerous. We can see pretty clearly that once we shoot a missile, the missile will have its engine or whatever propulsion system it's using on for the entire duration of its flight. So again, according to Newton's second law, if that's the case, then the missile is actually accelerating continuously as it goes towards the target. So the reason why that might not be a good thing is because the more kinetic energy your missile builds up, the more expensive any maneuvers will be after that. Changing its trajectory will be very costly in fuel. So this is one of those cases where the art team probably took some liberties regarding how the missiles would probably work in vacuum, because in sci-fi you always want to connect kind of futuristic looking technologies and stuff with what we have today, right? It needs to be somewhat relatable, otherwise it'll only appeal to super hardcore sci-fi people. And I think Frontier wants to appeal to a broader audience, so it needs to put elements in the game that we can kind of relate to. Like, oh yeah, I've seen missiles before, I've seen Top Gun or whatnot. I see how this works, and this is probably the thought process behind the art for missiles. That being said, it's still pretty interesting to speculate as to how an actual realistic missile would work in Elite Dangerous. So I've thought a little bit about the issue, and one solution is to compartmentalize the solid propellant in such a way that it allows for small controlled burns. So each of those burns would have a fixed delta V. Another solution would be to use a oxidizer fuel mix that would be hypergolic, meaning that it would burn in contact with each other, and then the missile would simply control a valve that will allow it to turn on and off the engine according to the need. So as you can probably tell, the design philosophy behind this propulsion system would be something cheap, right? Because missiles are consumables. You don't want to spend a lot of money and tech and that kind of stuff in a missile that is basically just junk after you shoot it. So now that we've talked a little bit about the dynamics of a missile flight and propulsion systems, we're going to talk a little bit about attitude control. So attitude is basically how your body is oriented. This is done according to three axes, which are pitch, yaw, and roll, also called your Euler angles. And basically, it's important because your propulsion system is fixed to your body to some extent, and so the orientation of your body is therefore important. So as we said previously, on missiles today, control surfaces allow for attitude control. As you can imagine, control surfaces are pretty darn useless when you're in vacuum, so you can't rely on that. So basically, you have to rely on other methods to be able to orient yourself in space. So I'm going to focus on mainly 4 methods of attitude control in space that are actually used today in industry. There are more than that. Obviously, you have things like magnetic torquers and things that use the magnetic field of the Earth to achieve some level of attitude control. But those obviously are not very relevant for the use of a missile. So the first method is actually quite simple. It's just to attach your propulsion system to a gimbal. So this allows you to move your thrust vector away from your center of mass, and this will result in a moment. The second method also uses propulsion, and basically it's the use of reaction control thrusters. So those who play Kerbal Space Program will be very familiar with this term, but basically you place little thrusters around your body, and then turning those thrusters on and off will allow you to cause moments on your body. The third method is to use reaction wheels. So the way reaction wheels work is quite simple. They're just simply wheels that you have on your body, and when they turn, because of conservation of angular momentum, your body will start spinning in the other direction. Now, I just want to point out that when I say body in those videos, I'm talking about, your object, like the missile, right? I'm not talking about a human body here. That would be interesting. So moving on to the last method. The last method is using gyroscopes or gyrostats. The way this works is you have a wheel that's already spinning pretty fast, and this wheel has a angular velocity vector, and this angular velocity vector does not want to move. Now, if you force it to move, if you force the wheel to rotate in a specific direction, it'll complain by inducing a reaction moment, and so use that reaction moment to achieve attitude control. All this being said, what method would a missile use in Elite Dangerous for attitude control? I think it can be a mix of several. Looking at the missile design in Elite Dangerous, we cannot see any thrusters on the body of the missile, so I don't think there's any reaction control thrusters, so method number 2 can be crossed out. I personally think that missiles would be better off using reaction wheels rather than gyroscopes, and the only reason for that is because for a gyroscope to be efficient, it needs to start rotating before the missile is fired, and I don't think that's a very practical method for a missile. It is for a spacecraft, but not necessarily for a missile. And finally, last but not least, we have a gimbal propulsion system. I personally think that this is a very appropriate way to achieve attitude control for a missile, and so my personal opinion is that a realistic space missile would be using a combination of gimbal thruster and reaction control wheels. Okay, so let's try to get a mental image of how a realistic space missile would fly. When launched, the missile would probably perform an initial burn, probably a second or 2 max. The engine would then turn off and the missile would simply drift in space towards the target. As the missile approaches the target, it would perform little burns and course corrections along the way to try to stay on target. The scary thing is, being shot by that kind of missile, you probably wouldn't see it until it's close enough that it can do a lot of damage. It's actually kind of creepy to think about. To conclude this video, I'm going to briefly talk about guiding systems. Currently, air-to-air missiles use mainly 2 types of sensors for guiding, infrared and electromagnetic or radar. The first is used for close-range combat, generally below 30 kilometers. The sensors and guiding systems are usually all integrated inside the missile itself, making it a shoot-and-forget type of weapon. Radar-guided missiles are usually used for longer-range targets. A radar-guided missile will rely on a third-party radar to be guided to the target initially. This is usually done by the shooting plane. When close enough to the target, the missile will actively track the target using its own onboard sensors. So from this description, I think it's pretty clear that missiles in Elite Dangerous use an infrared type of guiding system. Using infrared in space actually makes a lot of sense since there is less infrared noise there. A target tracking computer doesn't have to differentiate between a rock, a tree, a vehicle, etc. Yes, you have stellar bodies, but their infrared signature is actually pretty different from that of a ship. You may be wondering, why don't they just do like in The Expanse, strap a nuke to the tip of a missile and shoot it for miles and miles and miles, and then it just blows up a ship in one hit? My personal belief is it has to do with the frame shift drive. So if you're being targeted by a missile and your missile is 200 miles away, you have plenty of time to just jump to supercruise and dodge it entirely. Therefore, it makes missiles only relevant in closer quarters a few miles away, which is how they are used currently, at least in Elite Dangerous. So that wraps up this video for today. I hope you learned something new. I hope you have a better mental image of how a realistic space missile works and maybe how the ones in Elite Dangerous work. I think it's pretty fascinating to try to think about how those technology could practically work, and that's really why I like doing those videos. I know this went a little longer than they usually do. I hope it didn't bore you. I would like to thank the 5 subscribers I have for sticking around, and I hope you like this video too.